Hello, thanks for joining me. My name is Evan Floden. I'm the CEO and co-founder of Sakera Labs. A little background on myself, originally a bioinformatician, really spent the last 10 years working on Nextflow and building out the Nextflow ecosystem. And the last 5 years in terms of founding Sakera and building with customers on Nextflow and a range of other technologies. I think one thing that's been really core to that is enabling scientists to use modern software engineering tools. And today, my talk is going to be titled Beyond the Code and how we can empower scientists with those same modern software development tools and how they can be applied to their work. If we step back a bit and think about how software is developed now, it's changed quite a lot in the last 10 years. If we think about code and how that is generated now, whether this is code which has been written in IDEs like VS Code or generated from things like Copilot, this kind of shift in the way that people are developing this code has really made a big impact on software development teams. Likewise, with things like source code management, obviously GitHub has enabled a huge movement in open source, but it also applies to the enterprise and how organizations come together to build that code. Containers, obviously, the rise of Docker and Kubernetes in terms of the packaging and delivering the execution of that code. And of course, the cloud in itself and the way that the cloud is able to scale up the delivery of software, also to be able to scale up the underlying compute that's required, the storage that's required, the networking. All of that has been really key to the way that software is being built and the kind of types of software that has been built in that period. Testing is also really key here. Nowadays, most folks are continuing to build in unit testing and integration testing all the way through, as well as things like project management, which is applied across the organization. So with all of these developments which have taken place, I guess the real question is, why haven't scientists have been adopted and benefiting this? And I guess the question is, well, what's so different about what scientists are doing? And why are scientists different when they build their software or when they run their analysis? One way I like to think about this is thinking about data analysis lifecycle for scientists. So what's the kind of work that scientists are doing? Because it is different. It doesn't necessarily map sort of one-to-one with the kind of software development lifecycle, which is sort of well known and has been documented for a long time. If we think about the development, I think that's the piece which is more key. Whether this is people developing scientific tools, there is obviously a lot of testing which goes into the development of scientific software, delivery via containers and IDEs. The data itself, is somewhat different from when you're doing software development. How can you link in the data that you have? Long-running executions or this batch computation is kind of very key to what scientists are doing, as well as interactive applications, things like Jupyter Notebooks or RStudio. How can we build out those applications? And then the kind of analytics and reporting is very important for compliance, for again, the provenance of what you're doing. And the cycle, there'll be folks spending more time in some areas, more time in other areas. But overall, it kind of maps in some ways sort of what most scientists are going to doing on a day-to-day basis. If we think about that convergence, and this is something that we've spent a lot of time sort of building towards with Sakera, is thinking about that kind of convergence of what's been happening in the bio side. So particularly as it relates to sequencing, as it relates to some of the more technologies that are high throughput, it's obviously putting a lot of pressures on the software that's developed. And in conjunction with that, the software side of things, how can we bring those two things together and make it easier for scientists to be able to focus on the science, and whilst at the same time leveraging this technology for that? I guess one of the answers would be it's not that all scientists have been ignoring this. The software side of things has definitely been adopted by many folks. If we look at inside Nextflow in particular, so Nextflow is a workflow manager. I think when you think about the workflow management piece, it's been around about 10 years now. And there has been an acute need for scientists to be able to run things at scale. And that kind of scale does definitely put pressures on things where maybe it wasn't necessarily in kind of a low throughput places. What Nextflow enables scientists to do is to use those tools. So it has support for containers, where every task is a containerized execution. It has support for Git, in the sense that a pipeline can be defined as a Git repository, managing the source code, as well as being able to have the revisions, so you get the reproducibility from that, and the ability for people to really collaborate and have those pipelines open and be shared with folks. Once you've got a pipeline defined, you can then go run that in different environments. And this is kind of key to the ability to develop locally on your laptop, to be able to put that up into the cloud, or to be able to share it with a colleague who may have a Slurm cluster somewhere else. So that ability to have these different executors as it applies obviously provides a fair bit of requirements as you can think about it from modern software tools, which you'd be able to run in multiple different places, as well as the parallelization and in the storage, which is really key given the kind of volumes of sequencing data and imaging data and kind of scientific data more generally. Nextflow's really become a standard of this, and as we see it, like particularly as it relates to both the number of executions, so we see about 2 million executions per month now. We've got about 13,000 people in the Slack community, people contributing pipelines. And we also see like about 2,500 people who are GitHub contributors. So that kind of growth of Nextflow has continued, and there's obviously been an appetite, and I guess a growing appetite of people who want to use these tools and can see the value of these tools as it applies to their daily work. When we think about Sakura itself, this is really the embodiment of that, but being able to apply that a little more broadly, not necessarily just focused on the workflow execution piece. So we started Nextflow in 2013. Later on, we've got Phil and Alex who created NF Core more recently. It was the idea of the community coming together to develop those resources. And then Sakura was founded in 2018. In the time since then, we're now to about 125 customers. And when we think about those customers, it's primarily in the life sciences area. They're obviously running a lot of kind of compute here. And really a lot of that drive is coming from folks who are developing those pipelines, developing those pieces of software, but then wanting to make it available more broadly to scientists. And this is where some of the newer things that I'll speak about in a moment have come about. We're also obviously very focused on the community, and I think community and open source and software development all go together very well. We think about the pipelines which can be placed on Git. We enable folks to come together to collaborate, to share ideas, to share tools, and inside Sakura, we're big advocates of this, and continue to kind of push and support these communities as well. On the platform itself, the way we've built this up is thinking about the kind of core open source tools that we've been developing for multiple years, but also thinking about how you can integrate that with the existing tools that you use. So when we think about what tools that scientists may already be familiar with, they may have some data already in object storage in the cloud, in S3, for example. That may be the base location. We start to see that kind of more and more. You may have a Slurm cluster, which you're using, or an HPC system, sort of more generally. Most folks are going to be becoming more familiar with containers, particularly at a high scale. So enabling them to use those existing technologies, those existing tools, and not necessarily prescribing in some way exactly to build things into a platform, but really to provide visibility on those resources that already exist. If we think about the core functionality, though, it's really around management of data. As we said from the beginning, this is kind of key to what scientists are doing. High throughput batch execution, as well as things like notebooks and being able to have that interactive experience. In terms of that, we've been linking in with the resources that folks already have. This is enabling, for example, the view of object storage across different regions. So as scientists necessarily don't want to have to access the AWS console, for example, to be able to browse their data. Can make that kind of a visibility on those resources across different clouds, across different regions, across different accounts, as well as pull in public data sets. And we start to see more and more common for folks to be able to be using sort of object storage as a kind of source for public data as well. We've also have a new product coming out called Data Studios. The idea around this is to take the learnings from Nextflow as it relates to use of containers, use of Git, being able to define things and run them in any environment where the data is, and using that to apply to interactive environments. So this is launching in a couple of months' time with Jupyter, with our studio, with VS Code, but really any containerized application. And the idea around this is to use those tools. And this audience, we believe, is obviously much broader than the sort of high throughput batch-like execution pipeline bioinformaticians. However, as part of that, there's also a need to be able to make this technology easier to use. And I'll speak a little bit about how containers work and how that kind of feeds into some of the other work that we've been doing. Onto the Fusion side, and this is one of our other products, and what this is enabling you to do is mount sort of object storage inside of containers. When we think about the size and the volume of the data which is being used here, and it's part of the pipelines as well as in studios, being able to do this in an efficient way has been really necessary. And so with Fusion, we're able to mount that object storage inside the container and reduce costs significantly as applies to the pipeline executions. With Wave, it's really the ability to build containers on the fly. So many of the things that are kind of have come from Docker and sort of the advantages that we've seen from Docker, they've been fantastic for folks who are, say, running in an environment maybe where things are very stable, where you want to run things in production. But if you're in a situation maybe where you don't necessarily want to build a Docker file for every one of your processes that you have, you may have 70 different processes, or you're a user who maybe doesn't necessarily know how to build a container, how can we make that easy for you? And the idea with Wave is to flip the problem on its head. Instead of having to define a Docker file and then building the container, pointing it to the URL of that, you simply, as a user, define what you want, which dependencies you need. And from there, the container is built behind the scenes. It also enables you to augment containers with particular pieces of technology. But from a user's perspective, they don't even have to know that they're using containers. They simply specify the work that they want to do, the dependencies that they necessarily need, and behind the scenes, the containers can be automatically built as part of that. Reporting is obviously a big key of this as well, and MultiQC has been around for many years. It's really the leading tool as it relates to the reporting and bioinformatics, and this is something that we continue to build on. As we think about this, it's really enabling this kind of open source reporting, so any tool that gets developed, including custom tools that you have, captures the logs from those and be able to get those results, and really kind of a key part of what we do with Sakera, and making it easier for scientists to kind of use some of those open source tools and that software and end up by generating sort of beautiful reports that can be passed on and be customized as required. Also, the efficiency is really key here. So if we think about folks moving to the cloud and moving to adopt some of these technologies, making sure that you can do this in a cost-effective way. We've got some pipeline optimization, which we use, which makes it much more simple to really select the right amount of CPUs or right amount of memory, for example, for those pipelines, and those efficiencies really come through. Overall, if we see this sort of applied to all these things together, the use of spot instances, the use of optimization in terms of selecting the right resources per task, resuming pipelines, a lot of the things that come with moving to cloud, with kind of moving to these technologies, trying to make it in a way which is very simple, and it really leads to efficiencies across the board. Look at some of our customers as well who have kind of adopted this, as you see here. So really kind of thinking about going beyond the code, reducing those costs and empowering the scientists. We've got Sage Bio here. There's a 50% just a reduction in the costs on EC2. We also see folks like AdGene, where they're able to reduce the effort which is involved in terms of manually curating things. And even across like biotech, like Tessera here, where it's just that improved productivity which comes from moving to a kind of modern software development tools, but also having the ability to kind of do this in a way which is empathetic to what scientists do and what they have as part of their daily work. So with that, I'd like to thank you so much for the time. And if you have any questions, please reach out to the folks at Sakera. We're always available if you'd like to run a demo. We'd love to speak through your problems as well and see how we can help you and as it applies to them. Thank you so much.